Okay, so today we're going to be looking at solving equations, addition and subtraction methods. So when we're solving for equations, we're solving for an unknown variable, so something we don't know the value of. So I have two examples up here. One is x plus 2 equals 5, and the other is x minus 7 equals 3. The reason for this is because I want to show you how these two are done the same exact way. You find the unknown the same way. And I want to show you two methods that are used to solve equations using addition and subtraction. The first thing that's important to know is that addition is the inverse operation of subtraction, meaning that if I want to undo addition, I would subtract whatever was being added. If I wanted to undo subtraction, I would add whatever's being subtracted. They undo each other, they're inverse of each other, they're opposite operations of each other. And that's why they're grouped together whenever you're doing order of operations. Now, something else to note when it comes to addition and subtraction and when solving them is that equations are equal expressions, two expressions that are set equal to each other. And so if two things are equal, they're balanced, right? Right? They're balanced. Meaning that if one side had too much, the other side would go up and it would go down like a seesaw, right? We want them to be perfectly balanced and still. So, with that being said, if you were on a scale, if you added more stuff to one side, you would add the same amount to the other so they stayed balanced, right? If you subtracted things off on one side, you would take more things off on the other so that they would remain balanced. It's the same thing that we're going to do over here. So we know that x plus 2 equals 5. Well, the first method we're going to do, we take the operation that we see and we do the opposite. So we have x plus 2 equals 5, so the opposite of that would be subtracting 2. Now, if we subtract 2 on one side, we're take something off, right? So take stuff off, this rise up, it's not balanced anymore. I want it to be balanced, so I took 2 off on this side, I need to take 2 off on the other so that it can remain balanced. And a lot of times people write it this way because you can clearly see that we're doing 2 minus 2 and not really x minus 2. And same thing here, 5 minus 2, because we can do that, right? If this had been x minus 2, we would just put x minus 2 down because you can't actually combine those terms together. See simplifying expressions if you want more info on that. Now, x plus 2 minus 2. And if I want, just so you get used to it, I'm going to write that x plus 2 minus 2. And I'm going to write that this side is 5 minus 2. Well, 2 minus 2 we know is 0. So this is just x plus 0. And this side is 5 minus 2, which would be 3. Well, although 0 is a constant and x is a variable, what do you get when you add 0 to something? Oh, that's right. It's still the same. So x plus 0 would just be x, regardless of the fact that 0 is actually a constant. Well, we can't add those together, can we? Anything plus 0 is going to be itself, so that's fine. And so we end up seeing that x equals 3. Many of you probably were like, oh, I already knew that from the beginning of the problem. How'd you know that? Because you knew that some number plus 2 had to equal 5, and the only way that's possible is if that number is 3. You did algebra up here based off of a number fact, because you know that 3 plus 2 has to equal 5, so therefore x must be 3 because that's the missing part of the number fact that you know. Or because you know that if I add two things together and get a sum, I can subtract one of them from it and get the other, because that's the way addition and subtraction work with one another. Or if you just knew it because you solved the equation as we did here. Okay, great. Let's take that same mindset, though, that we just did here out of any of those things I just talked about, and do it over here when we're doing x minus 7. Now this time, we have x and we're subtracting 7 on one side. So for us to put it back, or to undo the subtraction, what will we need to do? Oh, well, the inverse of subtraction is addition. So I'm going to add 7 on both sides. Why both sides? Remember, we're trying to keep it balanced. If I add more stuff on one side, I need to add it on the other so that we maintain that balance. Okay? So in this case, I get x, let me do this. I get x minus 7 plus 7 equals 3 plus 7. Okay, great. Well, x minus 7 plus 7 is the same as x plus 0. And 3 plus 7 is the same as 10. And if you had trouble with that, look back at your addition and subtraction of integers. Negative 7 plus 7 is 0. That's not negative 7, that's minus 7. Well, it's the same because subtraction is just negative addition. Okay, so we end up with that x has to equal 10. Well, I already knew that from the beginning because 10 minus 7 has to be 3. That's right, it does. Maybe you knew that from a number fact. Maybe you did the algebra in your heads. Regardless, you can solve for these unknowns, especially when it's an addition or subtraction method. Generally, this is the easiest part for people. It's all still simple, but usually this is the easiest part for people because they feel like they don't have to do anything else. They don't have to show this work. I said this work. I didn't say show your work. Because there is another way for you to show your work. You can write down, for instance, that, hey, x plus 2 equals 5. I know for a fact that 3 plus 2 equals 5. Therefore, x must be 3. That is showing your work because you're saying, I know this fact is stated that 3 plus 2 equals 5. Therefore, x has to be 3. You can also show your work by saying, well, if some number, and actually let's do this, let's write it out. Because this is something that I saw a young lady do that I was tutoring like years ago. She would write out the problem, like with words. Kind of how when we were looking at taking a word problem and changing it into an equation, she would do it backwards. She would take a equation and change it back to a word problem because it made it easier for her to see what it is that she wanted to do. And so let's do it for the first one here. So we have x plus 2 equals 5. So what she would do is she would say, well, I know that some number plus 2 equals 5. And then what she would say is, I'm going to start at 5. And instead of plus or adding 2, I'm going to do the opposite of that. Because it's the only way I can go backwards is if I do the opposite of that. So what's the opposite of adding 2? 5 minus 2 is some number. So what she would do is she would write out what the problem is actually asking, and then she would do whatever is happening to this in this problem backwards, doing the inverse operations, because that's how you would do it backwards. If I were to add 2 to a number, so like say if I'm looking at a number line, here's where x is, and I add 2, and I say I'm at 5, the only way for me to go back is to go backwards, which would be subtracting 2. Okay? But she understood that when it came to words, but not when it was written that way. And so she just changed the way it looked so she could work with it. And she could do this every single time, no matter how complex it got when it came to these singular powers of x, no matter if it was multiplication, addition, subtraction, which all we'll look at later. If it was a combination of it, by writing it out and working it backwards, she was completely fine with it. And it was the most amazing thing for me to see because I was able to give that to people learning algebra again and who freaked out when they saw this problem 4, who couldn't understand to subtract 2 on both sides of the equation. They couldn't understand the balancing part of it. They couldn't understand why. They couldn't see it visually, but for some reason when this is written out, they could see it. So the point of that story, honestly, is 1, to show you another method. 2, to show you that a lot of times people believe that there has to be these multiple processes in math. So here's algebra. As I told you, it's really just doing operations with numbers. Uh, Honestly, just doing operations with groupings of symbols and things that mean different things. But anyway, just say numbers for now. And they take, oh, this must be different now. This must be different now. This must be different. This must be different. This must be different. Instead of scaffolding it on top of each other, saying this is all just an extension of this one thing. And if you think of it that way, because that's what it really is, it's just an extension of one thing, this becomes a lot simpler to do. And if you don't even want to have to write it out, but you can say in your mind, I have something plus 2 equals 5. What is that number? It may make it easier for you to solve. So find your method to solve these addition and subtraction equations. Hold on to it fast, stick with it, but don't let it turn into multiple processes. See the underlying root behind it. And speaking of seeing stuff, I'll see you soon.